everybody. Today is week 1, day 4. And my name is Mr. Roll. I'm principal teacher, and I'm over here with Miss Frank, who's our 3rd grade teacher. So we're here to do the announcements and the pledge and joke. So first up for announcements, we actually have an announcement about Miss Frank's classroom. So we are going to bring the camera over to Coach Fryer, and he's going to surprise us with our announcement today for Miss Frank's classroom. Go ahead, Coach.
Hey guys, good to see you again. It's Coach Fryer coming at you from Miss Frank's room in the Curie building. Just wanted to say good morning, and I hope everybody's doing all right. We wanted to give you an update on the new carpets in Miss Frank's room. So as you can see, they are nice and charcoal grayish, so we won't see any stains or anything like that. It smells awesome in here. I wish you guys could smell it, but I'm sure it'll be still smelling good when you guys come back. So this year, obviously it is Miss Frank's room, but next year this is actually going to be our new middle school classroom. So middle schoolers, hope you're getting excited, getting some nice new carpets in for you.
Thank you, Coach.
Yep.
Well, I'm so excited to have new carpet in the classroom, and boy, I'll be even more excited when you guys come back to school and you'll be able to enjoy that new carpet with me. But the joke of the day is, for today, the joke is, let's see, what kind of plates do they use on Venus?
I don't know, Miss Frank. What kind of plates do they use on Venus?
Flying saucers.
Flying saucers, get it? Because it's another planet in space and stuff like that. All right. Okay, go ahead, Miss Frank.
Stand at attention, please. Place your right hand over your heart, and let's say the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, thank you so much, Miss Frank. Let's go ahead and get to our classes for the day. We'll see you guys around. Bye. All right, we're back for week 1, day 4. As you can see, I'm still having an awful time with the lighting, so please bear with me. So for today, same schedule as normal. Okay, we're beginning with life skills. We're moving on to social studies. We're going on to literature, science, math, and then at the end, I'm probably going to have to drop in a separate link for Miss Kimmy's grammar if I can't integrate it directly into this video feed. Okay, well that is the agenda for today, so let's go ahead and begin. Okay, so I had to change positions because the device I'm recording on is on a low battery and I had to plug it in. But it works for me because I stole some snacks from Miss Kimmy. So, let's talk about life skills. I don't think I'm going to be able to eat and talk at the same time. So yesterday we talked about boredom and how important it is to have boredom so that you can become a deeper thinker. And that is true, not making that up. Now, if your life is busy, okay, I know a lot of you are taking care of little brothers and sisters, a lot of you have a lot going on with your families and stuff like that. If your life is busy and you don't have time to be bored, that's one thing. But if your life is full of fluff, your life is full of meaningless entertainment, that is a problem. It affects your ability to, again, think deeply, and it affects your ability to focus and concentrate. And so this is maybe not the best idea, and I want to get your feedback from this, okay? I wanted to do a concentration exercise with you over the video. Now, some of you are watching this video right now on your device, and it's just on normal speakers, and maybe you're in a room with your parents, or there's a brother or sister in the room with you, and so they might be looking at you right now being like, is he really going to do it? Is she really going to do this concentration exercise? I don't know if you are or not. If you can though, if you have a pair of headphones, maybe put those on and maybe try to find a quiet corner of the house where you're all by yourself, and let's do it. Okay, let's do it. And so go ahead, if you need to pause the video, and take your device to a quiet corner of the house, and let's go ahead and do a concentration exercise. And today's concentration exercise is going to be very simple. I am not going to be guiding you on this one. I just want us to stop, and we're going to think. So find that stop, or find that part of the house. Let's stop. Make sure that you're in a good place where you have good posture. You're sitting up straight. You're breathing in through your nose and out through your mouth. Go ahead and take a few deep breaths. In through the nose, out through the mouth. I want you to close your eyes and focus on the sounds around you. After you spend a minute focusing on all the sounds around you, I want you to start thinking about the good things you've had in your life over the past week and a half. Over the past week and a half that you've been at home, what are some of the good things that you've had in your life? Those good things might include a parent. It might include a friend or a sibling. It might even include maybe your favorite YouTuber or your favorite person on social media that you like to talk to. So let's take 1 minute and let's focus on all of the good things in our life, and also focus on the sounds around us as we sit breathing in through our nose, out through our mouth, and keep our posture straight and our eyes closed. 1 minute begins now. All right, open your eyes. I don't have a timer going, and I think that was about a minute. And so go ahead and send me an email. Tell me if that was weird and you don't want to do it again. Tell me if you liked it and you want to try that again, okay? But get in the habit of doing things like this on your own. Get in the habit of focusing your mind and finding, again, times for deep thought, for boredom. All right, it's time to go on to social studies. And I think I'm going to keep on sitting here because, again, my device needs to charge. So, all right, let's do some social studies. All right, so I have decided that for our social studies, I'm actually just going to sit in this chair and let my device charge while we have a discussion about current events and about history. So, first, let's talk about history. No, I'm sorry, current events. Current events comes first. So yesterday we took the contraction one step further, and we started talking about the unemployment rate. We talked about recession and depression, and we talked, actually that's it, we just talked about unemployment rates and recessions and depressions. So a quick review. The unemployment rate is the percentage of people in an economy that are able and willing to work who can't find a job. People who can work and want to work but can't because they don't have a job, okay? Is that right? Yeah, people who are able to work and want to work but cannot get a job. That's what the unemployment rate is, okay? And we also talked about full employment at the end of the lesson. Generally, for the United States, full employment is considered to be close to 4%, okay? And so I'm going to keep it a little bit shorter today and talk about recession and depression, okay? There is an old saying in business that economic expansions do not die of old age. Again, let me repeat that. Economic expansions do not die of old age, okay? And so the idea is that when we go into an economic recession, there's always a reason for it, okay? Recessions don't just happen at random, they happen for a reason, okay? I should say recessions, depressions, contractions in general, okay? Earlier in the year, we learned about Andrew Jackson and how he destroyed the Second Bank of the United States. And the destruction of the Second Bank of the United States didn't do anything during his presidency. But then later on, when Van Buren became president, his best friend, it caused the United States to go into a small depression, a giant contraction, okay? Contractions are caused for problems, or are caused by problems. Pretty much all recessions happen for a reason, and that reason is typically a problem, okay? And so that's what I want you to understand today. Contractions are caused by problems. The contraction that happened in the United States after Andrew Jackson, okay, our 7th president going into our 8th president, Martin Van Buren, that contraction was caused by the closure of the largest bank that the people in America used, the Second Bank of the United States. We had a contraction in the 1970s here in the United States, and there were multiple reasons for that contraction, but one of the big reasons was caused by oil, okay? Americans relied on oil to a great extent, and we did not control the supply. And so when oil would become too expensive and we had to buy oil from other countries, that oil would then become a problem for people who needed it, like truck drivers and shipping companies and heating and utility companies, and for everyday Americans who needed these things to drive their cars and warm their houses, okay? Again, it was caused by a problem, all right? We had a contraction in the year 2001 going into 2002. That contraction was caused by the terrorist attacks of September 11th, okay? Again, it was a problem. The terrorist attacks showed America that we were not invincible, and it also shut down our financial markets for a short period of time, and that was a problem. We had another contraction in 2008, what we call the Great Recession. The Great Recession's contraction was caused by this very complicated thing called collateralized debt obligations that were being sold at a AAA rating when really they were junk bond status. You don't need to understand what that means. Basically, people screwed up and were lying to other people. And these lies got so big that it tanked the world economy. That's what happened back in 2008. So whenever we hit a contraction, the contraction is caused by a problem, okay? Today we're hitting a contraction, and today our contraction is also caused by a problem. And that problem's name is COVID-19. And so it's important to understand that it's no one's fault this time around. COVID-19 is a force of nature, literally. It is a natural phenomenon where a virus has jumped the species barrier from one species into the human species, and now we're all getting it, okay? And so this is causing us to be in a recession, or into a contraction. Definitely a contraction, maybe a recession. Again, the big takeaway from today's current event lesson, economic contractions are caused by problems. Done. As I'm recording, there you go. There we go. All right, so let's talk about Abraham Lincoln and wait, where are you? You're right there. Okay. So let's talk about spicy Cheetos. Let's talk about Abraham Lincoln, and again, this is something that's a little different. So I wanted to take a brief moment and talk about the significance of the Civil War, not just for America, but for like all of history. Okay, that sounds very dramatic. All of history, but it really was a significant war in historical terms, not just for the United States, but for the world. And the reason why was because of the time in which it was fought. Okay, so during the 1860s, if we look back at what was going on around the world, the United States was the only large functional democracy that was not ruled by a monarch. A monarch is a king or queen or emperor or empress or something like that. The United States, again, was the only large functional democracy that didn't have a king or queen or something similar, okay? If you look at the different countries in Europe, the only country that I think was similar on that level was probably Holland or the Netherlands. Okay, a lot of the ideas of equality and democracy that originated in Greece were practiced by the Dutch, and so that's where we got them. Perhaps you might remember. Oh, there's a car alarm going on outside. Okay, perhaps you might remember, but New York City was not always New York City. It was first named New Amsterdam because it was settled by the Dutch. And so the Dutch had these ideas of equality and democracy and of a representative government where everybody can vote. And in many ways, we borrowed the ideas for our country, like the founding fathers borrowed the ideas from the Greeks and the Dutch to just make it work on a much broader scale than the Greeks or the Dutch had ever done before. And so again, during this period of time, the United States of America was the only large functional democracy or a democratic republic on earth. And so when the Civil War broke out, all of the civilized countries in the world were looking at the United States of America to see if we would collapse. And so Abraham Lincoln, this poor guy that grew up in the woods in Illinois and who grew up and put himself, through his own education, never had a formal education, passed the bar exam just by sheer force of will and educating himself and apprenticing. This self-made man had the entire weight of not only the accomplishments of all the founding fathers, of Adams and Jefferson and Washington and Monroe and Madison. He had all of their accomplishments resting on his shoulders. But he also, in addition to that, had the fundamental concept of a representative democracy, okay? America was the only democratic republic, and if the Civil War was lost, the rest of the world would say, hey, democracy stinks. We're going to stick with our monarchs, who are much more organized than your silly little voting system of government. Okay? So again, all of the accomplishments of the Founding Fathers on his shoulders. The concept of democracy sitting in the balance, also resting on his shoulders. And then in addition to that, he had the well-being of every man and woman in the United States also resting on his shoulders. And I haven't even talked about slavery yet. He had the freedom of all African Americans also resting on his shoulders. Can you imagine that sort of pressure? And then in the middle of all of that, his son dies. Wow. Abraham Lincoln had a really tough road during the Civil War. And again, that is why we still to this day consider him one of the greatest men who ever lived. Because he met all of the challenges I just talked about, and he overcame all of that adversity to keep America a solid country, to prove to the entire world that a representative democracy was a system of government that could sustain itself. And it was because of Abraham Lincoln and what he did in the Civil War that we have countries like India today with over 1.2 billion people that all get to vote. So the influence of Abraham Lincoln in keeping America together and winning the Civil War led to the entire continent of Europe developing similar styles of democracy. And it led to literally billions of people on Earth getting the right to vote more than 100 years later. And kids, I gotta tell you, you might be thinking to yourself, well, Abraham Lincoln didn't know that that would happen. Yeah, he did. Abraham Lincoln was a deep thinker. And when you read through his diary, he actually goes through great pains to talk about the weight of responsibility that is on his shoulders, not just for his current generation, but for all of those to come. And so kids, again, we spend so much time on the Civil War because it was such a turning point in American and world history. That's it for today's lesson. You have a couple Khan Academy things assigned to you. Make sure you're watching them. Thanks, guys. So I think we're talking about literature next. Okay, so in literature, was it yesterday? You were supposed to read through the chapter. It was not the accident or incident. It was like the not enough air chapter. Yeah, not enough air. That's what it's called. So in not enough air, as I recall, remember the Nautilus is trapped underwater. Like the entire ship is trapped. Not between a rock and a hard spot, but trapped like in a bubble of ice that they basically can't get out of. And so Captain Nemo, as always, is super composed. He's not losing his cool, and he's just like, hey guys, we have kind of like two options to die. We can either be crushed by ice, option one, or option two, we can all be asphyxiated when we run out of air. What do you guys think? And so, of course, that is not preferable to anybody. And so the third option for them is to try and escape. And so they send divers out, and the divers are trying to find the shallowest, I guess, the least thick part of the ice, and then they're trying to dig through it. And then the Nautilus is also generating hot water, if I remember correctly, to kind of slow down the freezing. And long story short, it works, and they're able to escape. But a lot of people are thinking certain things about the leadership of the captain, perhaps, that put them in that needlessly dangerous situation. And so that was a summary of the reading from the other day. I think next week we'll start giving you guys reading quizzes, and you have to email me or something like that. But for this week, we're just reading. I'll be honest, I want to get through this book quickly, and so we can start on our next book, because I feel like we've been taking a little bit too much time reading through this. Not that it's not worth it. This book is great, but I just want to get on to the next. Okay, so tonight, your reading homework is From Cape Horn to the Amazon. And From Cape Horn to the Amazon will also be listed as a download in the audiobook form. So if you want to listen to it as you're reading through it, or even if you, frankly, if you just listen to it, I guess there's no way for me to tell, you can do that too. All right, so that's it for literature for today. So we're on week 1, day 4 of our science. And today I don't have any other videos for you. I wanted to stop today and talk for a second about light bulbs. Okay, so right here I have a box of light bulbs, and you all see that I'm struggling with the lighting here right now. Now the light that you see kind of reflected off the board is actually one of these light bulbs, and so here is one of the bulbs in question. It looks just like a normal light bulb, okay? Now this is an 8-watt light bulb, is that right, 8 watts? Yes, okay. And so it's a little bit confusing, as I don't know if you can see that on the package there. It says that it's a 60-watt replacement bulb, and it is only 8 watts. And so I'll get to the replacement idea in just a minute. But first remember that this light bulb is an 8-watt bulb, okay? And where's my thing? This board is getting messier and messier. All right, so let's talk about this. Yeah, you can see that here. So we have watts. Okay, and a watt is a unit of power. Okay, let me grab a different marker here. A watt is a unit of power. And so this is power. But we also have something called a watt hour, which is a unit of energy. Watt hour. And so our light bulb that I just showed you is 8 watts. And so if you asked how many watts is this light bulb, it's 8. And what does that actually mean? Well, that means that if we leave that light bulb, so if we turn this light bulb on, and if we leave this light bulb on for an entire hour, it will use 8 watt hours of energy, okay? So in an hour, the bulb consumes 8 watt hours of energy. And so that, it kind of makes sense. I mean, y'all use iPads and phones and stuff like that. So as time goes on, the bulb will have used up more and more energy the longer it's turned on. It's 8 watt power rating, and so in half an hour, it will have used 4 watt hours. In 2 hours, it will have used 16 watt hours, okay? And so this is how much energy the bulb consumes, okay? So that's energy, okay? Now, what else we're talking about here, we have this bulb's replacement, okay? And it says that it's a 60 watt replacement. Is it a 60 watt or 100 watt? Yeah, it's a 60 watt replacement, as you can probably see right there, okay? Now, the reason why it says that, guys, is that, wait, how many is this here? Yep, there we go. So back in the day, if you had 60 watts of power, you could use a light bulb and you could generate 800 lumens, okay? So again, a watt is a measure of power. A watt hour is a measure of energy, but if we're trying to measure light, we use a different unit called lumens. So light is measured in a unit called lumens. And so back in the day, when myself and all of your parents were growing up, the light bulbs that we used were not as good as the light bulbs we have today. And so back then, if your parents or myself, if we wanted to buy a light bulb with 800 lumens, okay? If we wanted a light bulb with 800 lumens, a light bulb with 800 lumens would take up 60 watts of power, okay? Again, meaning that a light bulb that outputs 800 lumens of brightness would consume 60 watt hours of power, of energy, after being left on for an entire hour, okay? And so today, though, the same 800 lumens can be accomplished with only 8 watts, okay? And so our light bulbs today are much better than the light bulbs back when I was growing up, okay? It's almost 10 times more efficient. And so we only have to use maybe like 1/10 or maybe 1/8 the power to get the same amount of light, all right? And so that's pretty much it for today's science lesson. We're kind of taking this slow because this was a concept that I wanted to talk to you about in person. You know, the idea of work and force, energy, even the idea of lumens. It's a little bit easier to explain in person where I can answer questions. I can make you stand up and follow me around and do things like that, okay? So we're gonna take it little by little. But again, a watt is a unit of power, a watt hour is a unit of energy, and a lumen is a measure of light, okay? And so those are the concepts that I want you to walk away from today's lesson understanding. Now, because we're just in week one, for weeks 1 and 2, I'm not gonna worry so much about testing you guys that much, okay? I'm more so worried about us being able to produce these lessons, for you to be able to access the lessons, for you to be able to continue learning. But in the very near future, we're gonna be a little bit more serious about quizzing you guys and about getting your grades, okay? And so for now, please be paying attention to this. Don't just brush it off because I'm not immediately quizzing you, okay? Because it will be tested later on. All right, so that's it for science for today. Time for math.
Hello. All right, ladies and gentlemen, it is time for Math Group 1. This is week 1, day 4. Okay, let me get my stylus going here. Get turned on. All right, so for today, for day 4, we are doing review. And so we have some review questions here that we're going to be working through together. Okay, so we are reviewing the concepts of area, of a rectangle, a triangle, and a circle. Okay, rectangle, triangle, and circle. So, first word problem here. Noah and Natalie are trying out different dog parks. The first dog park is a large rectangular field that spans 30, should be yards, on one side and 40 yards on another. The second dog park is a large circular field with a radius of 43 yards. The last dog park is on a triangular piece of land that is 100 yards by 25 yards. Which dog park will give their dogs the most room to run and play? All right, so let's work on this. Natalie and Noah are trying out dog parks here. Okay, so let's see here. The first dog park is a rectangle. Hey, oh, let me write. Is it going? No, it's not. Sorry, guys, technical difficulties, because I don't know what I'm doing. Why is this not working? Please work. I know that out there's like 10 of you who do this all day in class when you're supposed to be listening to me, and you're like, well, Mr. Roller, you just got to do that. How come you don't know how to do it? All right, I'm going to pause the video here. Give me a second. All right, group 1, I have come up with the ingenious solution of just using more than one note. So, again, we have 3 dog parks, one that's 30 by 40, another one that is 43 yards in radius, and the final one that is 100 yards, by 25 yards. Okay, so we have the 3 dog parks represented here. And so we want to know what? We want to know which dog park will give their dogs the most room to run and play. Park 1, 2, or 3. Okay, so looking here, this is 1, this is 2, this is 3. Okay, so we have to go ahead and find the area of each one of these shapes. And so on this first shape, oh, I don't know if I did a great job introducing this. Again, ladies and gentlemen, today we are not doing any new concepts. Today we are just reviewing concepts. After I review these concepts with you, then your homework is going to be to do a PDF that we have in the downloads folder. And I'm going to want you to download that PDF and work through that as your homework tonight. We're not doing Khan Academy. We are just working on the PDF. Okay, so on this first one, we have to take 40. Let's see here. These are all in feet. So it's 40 feet times 30 feet. Okay, because we're doing the base times the height. Okay. And then let's see here, 3 times 4, that is going to be, so we have 2 zeros, 0, 0, and 3 times 4 is 12. Okay, so this is going to give us 1,200 feet squared. Okay, so it's a cute little dog park, and so that is for dog park number 1. Okay, for dog park number 2, the formula is for the area equals pi times the radius squared, and so we have to take 43 and we have to square it. So 43 times 43. Okay, and so 3 times 3 is 9, 3 times 4 is 12. Get that out of the way. 4 times 3, oops. 4 times 3 is 12 again. 4 times 4 is 16, 17. Good. Okay, 9, 4, 8, 1. There are no decimals. So let's see here, we have that. And then next, we have to times that by pi. Okay, so we have 1849. Okay, and then we have pi 3.14, just like that. And just to make sure I'm not making any errors, and for the sake of time, let me run this by the calculator really quick. Give me 1 second. Okay, times 3.14. Good. Okay, so we get, let's see here, 5,805.86. Okay, so and these are, I'm so sorry, these are in feet squared, because these are feet and feet. So this is park 1. Okay, and then park 2 is 5,805.86. Oops, what am I doing? 0.86 feet squared. Okay, let's kind of separate that out a little bit. Okay, so it looks like park 2 is much bigger than park number 1. So park 2 so far looks like the best bet, but we still have one more park left. So let's go ahead and check out this last park. So this last park is 25 and 100. And remember, for these, we have to do 1/2 times the base times the height to give us the area of a triangle. So now we have to take 1/2 here, okay, to find the area. All right, 25 times 100 is 2,500, and times 1/2, we would have to get 1/2 of 1,250, okay, and that would give us 1,250 feet squared. Okay, so this is park number 3. So looking at these 3 different parks, park 1 and 2 are almost the exact same size, or I'm sorry, parks 1 and 3, the triangle and the rectangle, are almost the exact same size. Park number 2, though, is many times bigger. In fact, park number 2 is bigger than both of the other 2 parks combined. And so the clear winner for both Natalie and Noah would be park number 2. All right, so that's how we do these problems. Okay, make sure that you remember how to do that for your homework tonight. We are going to do one more review question. Okay, oh, wrong one. Okay, last review question. Jordan wants to get Nikki, his friend on student council, to plan another dance for the middle school. To do this, he wants to impress her with the size of the local dance halls in the area. The Rotary Club has a circular event room that has a diameter of 300 feet. The YMCA has an event room that is a giant triangle, which is 300 feet long and 200 feet wide. Which hall should he use to impress Nikki to get her to plan another dance? No, actually, there might be a hidden message in this problem, folks. You know, just maybe. All right, so Jordan goes to the first dance hall, and it has a diameter of 300 feet. Okay, so let's do this together. So this dance hall is a circular space. Okay, it has a diameter. Okay, remember we have to have a middle, and the diameter cuts through the middle, and the diameter is 300 feet. So the diameter equals 300 feet. Now remember, the formula for area is pi times the radius squared, and so we can't use the diameter for that. But remember, a radius would have to be half of the diameter, so half of 300 is 150 feet, okay? So the radius here would have to be 150 feet, okay? So to find the area of this space for dancing, okay, we would take the area equals pi, and then times 150, because that's our radius, squared, okay? So now over here, let me go ahead and let's figure this out together again. 150 times 150. Put that space there because we're in the tens place. 0 times 5 is 0. 5 times 5 is 25. 5 times 1 is 5. Be 7. Good. Okay. All right. We have to put 2 empty spaces here because we're now in the hundreds place. Great. Let's add these guys up. 0, 0, 5. 7 plus 5 gives us 12. So we have 2 down here, 1 up here. There we go. Okay. So the area of this first venue or place to hold a dance, okay, would be 22,500 feet squared. Oh boy, that is a big, big space. So this is for the circular venue. So this is the first venue that Jordan goes to check it out, to impress Nikki. Okay, and let's see the second venue. I think it was at the YMCA. Okay, whoops. Oh, where are we? Here we go. Yes? Yeah. Okay. All right, and the second venue here is a triangle that is 300 feet long by 200 feet wide. Okay, let's go back. So with a triangle, it sounds like it's 300 feet long by 200 feet wide. So I'm guessing it looks like something like this, okay? And as we just discussed, to do the area of a triangle is 1/2 times the base, times the height. So we have to take area equals 1/2 times 300 times 200. All right, well, we can tell here that we have 4 zeros, 1, 2, 3, 4, and then 3 times 2 is 6. Whoops. 6. Oh, whoops, I should do this full screen. I'm sorry. Okay, so that's 60,000 times 1/2 gives us the area. All right, now, boy, that 60,000 looks kind of beat up. Okay, all right. So half of 60,000 is 30,000. And, oh, I'm so sorry, I forgot to list the feet. These are in feet, these are in feet. So this would be feet squared, okay? So 30,000 feet squared. These are large venues, okay? So a triangular venue is 30,000 feet squared. The circular venue is 22,500 feet squared. So we can say with some certainty that Jordan should try and impress Nikki with the triangular venue with 30,000 feet squared, a nice big place for us to dance and play some loud music and maybe eat some snacks. All right, so for your homework for this evening, please download the PDF file that is attached to today's entry on the website, and let's give that a shot. Please feel free to email me if you have any questions or concerns. Excuse me, I apologize for my yawning. I'm just a little tired. All right, well, we'll talk to you about math tomorrow and a bunch of other fun stuff tomorrow. See you then. Oh, it's time for group 2. All right, it is time to do some group 2 math. Okay. All right, so group 2, today we are not doing anything new. Group 2, I have some word problems here that we're going to take a look at. As I was working with group 1, I discovered that perhaps the easiest way to do this would be to just open up a new note. Okay, so let's read through the first word problem. So Hazel wants to buy a super duper Nintendo because she's bored and has run out of good manga to read. She notices that on average, the price of the $399 gaming console is falling at a rate of about $5 per week. When she does all her weekly chores around the house, she gets paid $12 per week. She has already saved $150. Using a graphing calculator, how many weeks will it be until Hazel has enough money to buy the super duper Nintendo and rub it in her sister Lucy's face? Aye, Hazel, that is so mean. Why would you ever want to do something like that? You know you should share. Anyway, let's go ahead and take a look at this. So the first thing we have to do is we have to break Hazel's allowance into one equation, and we have to break the console price into another equation to figure out when the two will meet and when Hazel is going to be able to buy this super great video game system. Okay, so we read in the question, let's start with Hazel. Hazel, and so if Hazel, and then our Nintendo, okay? So Hazel is making $12 a week, and oh, how much did she save already? I already forgot. I think I wrote this question. I did write this question. What am I thinking? Okay, so Hazel already saved $150, and she's making 12 a week. Okay, so Hazel is making $12 a week, $12 per week, and she already has $150. Okay, and this is going to be our first equation. And these equations are going to be done in a y equals mx plus b format because we are having to use a graphing calculator. We are going to solve this system of equations graphically. Yay! You could joke and say that graphically, I don't know if I spelled that right again, just don't tell Miss Kimmy. I think graphically is the best looking way to solve these things because it's with graphics. Ha, okay. All right, so that is Hazel's equation, $12 per week, and she already has 150. And so let's go ahead and take a look at the Nintendo equation. So the Nintendo equation, the system is already $399. Now, every week, though, it's actually not going up in price, it's going down in price. So every week it actually gets $5 cheaper. That's what she notices. So it's going to be negative $5 per week. Okay. So ladies and gentlemen, this is absolutely a system of equations, so I have to include my little math bracket there to show that these two things are related. Okay. So let me show you how easy it is to solve one of these things on a graphing calculator. Okay, so I have never done this specific problem before. I literally just made it up. And so we are trying to figure out at what point Hazel will be able to buy her Nintendo, and we're going to be using our handy dandy graphing calculator. Okay, so here we go. We're going to input first Hazel's formula, y equals 12x, okay, or 12 weeks, and we're going to replace the weeks with x for now. So she's making $12 a week, or 12 times x, plus 150, okay? All right, so did you guys see how that line just kind of disappeared? So when it was at plus 15, it was there, but when I made it plus 150, it disappeared. Now, the reason for that, if you think about it, right, is because this graph that I'm looking at, it only goes up to maybe the number 8 at the top and the number negative 10 on the left and 10 on the right. So what I have to do is I have to like pinch and zoom. Ooh, there's my line. Cool. Okay. So right here, you see where the line crosses the $150 point right there? 150. So that 150 point, this 150 point, that represents like right now, okay? So that y-intercept, we're at week 0, so the week just began. She has $150, okay? Week 2, whoop, okay? Week 2, she's going to have $162, okay? And so on and so forth. Hooray. All right, let's put the console price in there as well now, okay? And so the console price is falling, okay? But the console price, the equation for that was y equals, let's see here, it's a -5 because it's going down $5 every week, x, and the initial price of the console was $399. $399. Okay, there we go. Okay, and let's see, where's this line? Oh, there it is. Okay, so you see this blue line here. The blue line represents the console's price. Okay, the green line represents Hazel's money. And so using this graphing calculator, again, graphing calculators are super nice. I can just zoom out and boom, I can see where the two lines meet, okay? And that intersection point between the green line, Hazel's money, and the blue line, the falling value of the console, is exactly when Hazel will be able to buy the console. Great, okay? Now, our intersect is weird, okay? So the intersect tells us right here that Hazel is going to be buying the console in about 14 weeks, between 14 and 15 weeks, okay? So you can round that up to 15 or down to 14, it doesn't matter. So it's going to be around 14 and a half weeks it's going to take her to buy the console. And when she buys the console, if she is correct in the rate at which she earns money and the decrease in the console value, she'll only be paying about $325, okay? So, I don't know, she can expect around 15 weeks of having to save, okay? And she can spend $325 to get her super duper Nintendo. And 15 weeks kind of sounds like a long time. If you think about it, though, it's about 4 months. So it takes 4 months of work, okay? So, good deal, Hazel. 4 months of work, and you got it, okay? And so, again, you're going to be paying about $325 when you finally buy it, okay? It's not an exact amount, it's about, so we can put our little wavy about sign right there. And then it's going to take, we can just say, it'll take about 15 weeks. About 15 weeks, which again is really close to 4 months, okay? So that's not bad. That's our first problem today. We are solving that system of equations and we use graphing. Again, solving using graphing is one of my favorite ways to solve because it's really nice to have a graphic to look at to really understand your problem. Okay, let's go on to our next group 2 word problem for the day. There's Hazel. Ooh, this one's a long one. All right, let's read it together. Zamarius is trying to steal the embarrassing photos from Halloween off of Aiden's phone. After taking his phone at a sleepover, he plugs Aiden's phone into his computer and starts a brute force attack. Zamarius' hacking software begins by using a standard set of 400 common attacks, then generates 10 random attacks per second until the phone security is cracked. Aiden's phone has a self-healing firewall that can defend against 50,000 attacks initially, then heals at a rate of 5 attacks per second. Use a graphing calculator. How long will Zamarius have to wait for his computer to crack Aiden's phone? Assuming Aiden's awake, because again, this is a sleepover, he could be asleep. Assuming Aiden's awake, is it reasonable for Zamarius to assume that he can get the photos before Aiden knows his phone is missing? So Zamarius is fighting the clock, and in fact, in a lot of, I guess, penetration attacks is what they call it, a pen testing, penetration testing for security systems. Timing is everything. But however, the scenario I described is it's completely silly. Okay, so this is not how computer testing and penetration attacks work, but it's just a silly question for math class. So let's go ahead and do it. All right. So again, the big numbers. Okay, Zamarius' hacking software begins with 500 attacks and generates 10 attacks per second. Okay, so let's go ahead and go down here. So to begin our system, we have Zamarius. And so his thing generates 10 attacks per second. So we'll say 10x. Okay, so x is going to be seconds, equals seconds. So it generates 10 attacks per second. And it starts off with a basic number of 400 attacks. Okay, so it would be y equals 10x plus 400. Okay, now let's talk about Aiden's phone security. Okay, and so looking at Aiden's phone security here. Okay, whoa, what are we doing? All right, Aiden's phone can defend against 50,000 attacks initially, and then heals at a rate of 5 attacks per second. Okay, so Aiden's phone is going to be something like 50,000, like that. Okay, and then heals at a rate of 5 attacks. Okay. So we have Zamarius here, we have Aiden there, we have to add our brackets so we know that this is a system, okay? Again, if we're using a graphing calculator, these things are like magic. Back when I was a math student, I did not have the graphing calculator. One of my favorite things about these graphing calculators is their speed. I can readjust the window I'm looking at just by pinching and zooming. Again, it's so cool. All right, so let's use this graphing calculator to figure this out and see if Zamarius can reasonably hope to crack open the phone before Aiden realizes that the phone is gone. Okay, so we're going to start off. It doesn't really matter which one we put in first. We're just looking for the point at which they intersect. So let's go ahead and put Zamarius's computer in there first. Okay, so Zamarius's computer attacks at a rate of 10 per second. Okay, or 10, whoops, wait, where's my x variable? There we go, 10x. And then it starts off with a blanket attack of 400, okay? So we got that. All right, so that blue line represents Zamarius's computer trying to hack Aiden's phone. All right, the second line that represents Aiden's phone, y equals, well, his phone can heal at a rate of 5 attacks per second. So his phone heals at a rate of 5x, or 5 attacks per second. However, and this is why we're using a graphing calculator, because these numbers get really big, okay? His phone is already defending against an initial onslaught of 50,000 attacks, okay? All right, and so after we input the information properly, okay, then we have to take a look here, whoops, at the graph, okay? So let's take a look. That blue line, again, represents Zamarius's computer trying to brute force its way in. I continue zooming out, zooming out, zooming out. Oh boy, this graph is getting really big, huh? Oh, see, there's that yellow line, or that orange line, I don't know, whatever color it's showing up on your screen. And it is fast approaching. So the orange line represents the phone's defensive systems. And so, boom, right there at that point, again, the blue line is Zamarius's computer attacking. The orange line is Aiden's computer defending. And at a certain point, they intersect. So let's figure out what the coordinates are here. Okay. All right, so they intersect at 9,920, comma 99,600. Okay. And so the y value, or the 99,600, represents the number of attacks Zamarius's software has to do to Aiden's phone in order to crack it. Now, to be completely upfront, kids, that's actually, I mean, that sounds like a pretty low number in real computer hacking if you're doing like a brute force attack. You know, having to do it less than 100,000 times is really nice. Okay, this first number, though, the 9,920, that represents seconds, okay? So 9,920. So what we know from this, okay, is that it will take 9,920 seconds to break the phone, or to crack the phone, and that it will take, what is it, 99,600 attempts, or 99,600 attacks. Okay? All right, so the next part of the question is, if Aiden is awake and Zamarius has all this information, can Zamarius reasonably suppose that he can do this without Aiden noticing, even though it's going to take him 9,920 seconds? So let's try to break this down. 9,920 seconds, okay? And we're going to divide it by, or you know what? Let me do it the appropriate math way. So let's erase all this good stuff. Okay. Let's do this the right math way with units and all that special stuff. So we have 9,920 seconds. Okay. The measurement that we want to erase is seconds, so we put seconds on the bottom, 60 seconds on the bottom, and on the top we have 1 minute. Okay. All right, and so let's see here. We do the math for this. I'm going to use a calculator since these are large numbers. I want to make sure I get it right in a good amount of time. Okay. All right, and so what this does is it creates, okay, the seconds cancel out. Good. And so we get 9,920 over 60, and we have that. Okay. And so we can drop the zeros on the back. Good. So that gives us 992 over 6. And 992 over 6 gives us 165 and 1/3. Like that. Okay? So these are the number of minutes. Remember? Because we did that there. And so this would be, actually, I should have put it right there. Okay, so it will take Zamarius 165 and 1/3 minutes to crack the phone. And again, if we want to put that in another way, we can put the minutes here and convert it into hours by putting, again, the thing that we want to cancel out on bottom. So 60 minutes equal 1 hour. Okay. And then 165 divided by 60, okay, would give us 2. Well, I'm just going to round this a little bit. So the minutes cancel out, whoops, okay. And we get about, I'm going to make this wavy, about 2 3/4 hours. So for Zamarius to break into Aiden's phone, Aiden has to be without his phone for 2 3/4 hours while the computer tries to break into it. I think that that's possible. I think it's totally possible that if Zamarius can convince Aiden to play a video game or something like that and get really involved, or maybe even watch a movie, like a long movie, that this would be possible. Now, again, it's a little dicey, who knows? But if it took 8 hours or like 9 hours for the computer to crack the phone, then there's no way Aiden would know. But since it's only 2 3/4 hours, it's a possibility. All right, so those are our 2 word problems for the day for math. Okay, I hope that these were kind of a cute way to review how to use graphing to solve these systems of equations. For your homework for this evening, we are doing a PDF. The PDF document should be on the website. You can just download it from the week 1, day 4, and it requires you to solve systems of equations using the graphical method, the substitution method, and of course the elimination method, which we learned yesterday. Folks, if you have any questions or concerns, please send me an email and I will be happy to reply in a prompt manner. All right, ladies and gentlemen, I miss seeing all of you, and hope you're having a really good one. And this is it for the day's lessons. Have a great rest of your day.
All right, I think we're recording. Yeah, we're good. Okay, so for what are we talking about?